no matter if you have all of these things, you have AV, you have IDS, you're even manning a 24/7 SOC, you can get hacked into. Red teams that I've been on in the past don't try to get into systems. We try to get into systems in ways that we have not done so before. That is the challenge. If you try to just get into a system, you get bored really quick, and you probably move over to the blue side because it's a little bit more challenging. You have to be right every time on the blue side. Red side, you just have to be right once. So this is the problem. Governments, companies, everybody's really struggling with, what do you do if I'm already doing all of this? Why am I not covered? If you are doing all of that, the next thing is offensive assessments. This is critical. Very few places are actually doing this, and it is starting to get more and more of a thing with red teaming kind of getting into the limelight. After penetration testing for, about a 5-year period, that was kind of the thing where you would go through and checklist what you were able to accomplish in a network. Red teaming is getting us a little bit closer here. So what type of offensive testing should I do? Well, the first kind, like I said, penetration tests. This is finding common weaknesses. Most of the time you're working off of some type of a checklist. You have a CVE or you have a vulnerability scanner that's really telling you what to do. Second part is a little bit more interesting. This is kind of the latest and greatest, is red teaming. This isn't so much of a checklist, but what you're doing here is you're simulating the actual goals of the adversary, and you're using only those goals in order to accomplish an operation. And then the last part that is what we will be talking about today is the adversary emulation. This is where you pick an actual threat, maybe an APT group, FIN group, UNC group, whatever you want to call them, and you only use their behaviors and their TTPs in order to access a network and environment. And what you're doing there is telling your organization, you can't protect yourself from every threat at all times, especially as a large organization. Let's focus at the threats that you're actually worried about. If I'm worried that APT 28, APT 3 is going to hit me, let me make sure I've got my bases covered there, and then I'll go ahead and start doing the generic stuff. All right, so what does it take for automated adversary emulation to actually work? You have to know what the adversary can do. Obviously, you need to have those skill sets. In CALDERA, we're going to refer to these as abilities. We also build everything from the MITRE attack framework. As you saw from the intro slide, I am a principal engineer at MITRE. We do a lot of things based on this attack framework, and CALDERA is probably the latest one that is heavily using that. After we have an actual ability set, we want to have a decision engine that's going to decide, out of all these abilities, what are we actually going to do in what order, and how do we accomplish that? And the last part, the actual stuff needed to do the things. I need a server, I need agents, I need rats, I need infrastructure in order to pull this all off. And I need to be able to do it with various levels of stealth. And this kind of goes without saying, but this is the intersection of red and blue. What you're going to see today with CALDERA is a pretty powerful tool. It is developed originally in the blue space to help defenders. I've been on board at MITRE for about 6 months. I've been pushing it into the offensive space. And so what you're going to see is a combination of those two. So if you're a red or blue teamer, this is going to be very applicable to what you do for work. All right, so meet CALDERA. All right, what is CALDERA? If you have not heard of it to date, it is a framework for automated red team operations. Like I said, this came out in late 2017 originally. The stuff you're going to see today is brand new, and it's been out since yesterday. So the parts of CALDERA that are worth mentioning, minimal installation time. It's going to take you about a minute to set up. Essentially, you clone and you do pip install. As long as you do that, everything's in one package. Low overhead, it can run on a laptop, very little RAM, can run on any laptop. I've been running the server on Raspberry Pis, does not need much to run. Built off of MITRE attack. The quick technique development is one of our key things. You can drag and drop techniques. If you have shell commands in any language that you want to drop in, you can actually just drop them into the system. Just takes a few seconds to add them in. We've got hundreds of them at MITRE. We're unveiling a couple dozen that are going to be part of this original release. You don't need any programming experience to use this. Everything is going to be built-in tool sets using PowerShell, Bash, all of these things that you're already used to using. You can bring your own rat to the system now. This was something you couldn't do before. So if you have a rat that you like using, maybe you use PowerShell, Empire, maybe you use Metasploit, maybe you have your own rat. You can actually write a plugin now to CALDERA without touching any of the original source code, and it will plug into the rest of the system and run and use the decision engine that is behind the scenes. And this is now going to work on Windows, Linux, OS X, and Raspberry Pis. These are kind of the ones that we've tested on so far. It will essentially run on anything that runs executable code. Haven't I seen this before? 2017, we did do this release. The big thing in 2017, so what you're going to see here is we designed it, MITRE designed this originally for research, R&D. It came out of the R&D portfolio. It had a lot of limitations because of that reason. It was never intended to be a in-practice tool. The big thing and the big innovative piece that came out in 2017 is the smart planning. This is an innovative way to use a combination of AI techniques and machine learning to do the decision making. There were the limitations up there. So last night when I pushed up the code, what you're going to see is it's going to work on all platforms, low overhead, quick technique development. And then the two key things here is it's designed for practical use, and you can add your own techniques really easily. So you don't have to use something that's already prepackaged for you. You get full control over the system. And on top of that, we unveiled a completely new UI. So everything's fresh. We even have a terminal mode. So you can hop into a terminal. You can do it through the browser. Everything's brand new from that perspective. Why'd we do this? Enable more use cases. Before, when we were constricted only to Windows environments, that was obviously a very large limitation. And also, we want to support the community's use of automation. We've already been talking with a number of different people in terms of integration points. A lot of tests that we have are actually coming out of an inspiration from Red Canary, and we're actually working with them further in order to integrate lots of their tests into our system. And we're looking at other places that have modules such as Metasploit and other tools that we can integrate fully, so you'll be able to bounce between tools, taking the test with you. All right, so now let's look at those ingredients of adversary emulation and kind of tie them into CALDERA. So I'm going to breeze through this quick because I'm sure everybody here is already knowing a little bit about attack. So this will be a little bit of a refresher, but what can the adversary do? This is everything that we have technique-wise is coming off of attack. And if you're familiar with the attack matrix, you're going to see tactics and techniques kind of filling out this grid. And these are our big reasons why we have chosen the attack framework in order to be a base for CALDERA. In terms of inside of CALDERA, what does it actually look like? How are we implementing these techniques? So you can see here, I'll roll a few of these in. These are what the techniques look like. Every technique inside of CALDERA is a single file, and they're about that big. You can stick in the command field, you can stick any executable code that you want in any language, as long as you anticipate it is going to run on the system if you were to run it manually. And this is all you do. You toss on the name, the description, what tactic you have it tied to, and then you load them in. CALDERA is going to fetch and grab all of your YAML files at when it boots up, and it's going to load them into an embedded database, and then you're off and running. You have them at your disposal. So you can actually add new techniques at any point and just reboot the system. All right, how does the adversary decide what to do? This is kind of a fun little chart. So let's say that we wake up in the morning and what we want to do is eat breakfast. There's a number of different ways that we can actually accomplish this. So maybe we want to turn the TV on first, watch the weather next. We don't accomplish our goal, right? So this is kind of a very simplistic way, but this kind of, I think, gets the message across that we have a number of different, you can imagine this in the computer land here, you have a number of different techniques you can do. If you want to accomplish goal A, you might have to go through a number of abilities or techniques in order to get to that point, and this kind of drives that home. So let's tie this into what CALDERA can actually do. So this is a term called composing techniques. So we're going to assume right now that we have code execution, a rat running on host 1. And what we want to do is we want to exfil a bunch of data off of host 2. We're in the same network here. So what we've determined here is, okay, we know red. We want to exfil that data. All of these green boxes here are the techniques or the abilities that we have to do that. So the question is, how do we know which one we want to do first, second, third? The first way of doing that, out of two ways, is explicit. We might sit there as a red team operator and say, okay, I know what to do. I need to dump the creds first. I need to mount a shared. I need to do all this. I create what we would call a chain, and I'm just going to execute that start to finish. The second way of doing that is more intelligently, and this is one area that CALDERA really excels at. And this is where we take all the abilities and knowledge that we have, and we say, okay, let's run these through an algorithm, let's pass these to CALDERA's planning mechanisms, and let's have that make decisions dynamically. So it'll run one thing, it'll score the rest of its abilities, and then it will pick the highest scored one, run the next one, and then it will constantly score after every decision that it makes. Inside of CALDERA, we actually support both and a blend of the two as well. So you have a lot of ability based on which environment you're in for how you want to actually execute these decisions. And so what we refer to it inside of CALDERA is the decision chain. And so every decision that gets made is a link in the chain. So we're going to say that we have an adversary here. It's got a bunch of abilities. So these are potential links in the chain that he has. The first link that gets used, or the first ability, might be get process. We might be running on a Windows machine here. PowerShell command, and we might then hop over and say, okay, the second link chosen, we're going to get the services. And then we're going to stop a service based on the knowledge of the services we got prior. And then maybe an AV started to kind of notice that we're there, so we're going to sleep for 60 seconds, and we're just going to make no noise. So that would be an example of our decision chain. Obviously very simple. Once you start doing this at scale and you have lots of abilities and lots of techniques, you can imagine how that kind of grows. This ties into what is called a logical planner inside of CALDERA. So the logical planner is a code module written in Python, as the CALDERA code base is written in, and the logical planner is our decision maker. This is what determines that decision chain. We have a bring your own planner modular framework right now. So we've released one planner along with CALDERA called the Sequential Planner. It's a very basic planner. It will run all of your techniques against all your hosts in order. This is a single file. It's only about 50 lines long, and it can plug into the rest of CALDERA, which means you can actually write your own algorithms and your own decision logic and just replace our planner with that or swap both of them. So it gives you a lot of ability and control to create your own logic here. All right, the last ingredient of automated adversary emulation, the stuff needed to do the things. All right, so inside of CALDERA, we have a core code base. Everything is centered around this core code base. So if you go on github.com/mitre/caldera and you just do a git clone, you're going to get the core code base. If you do a git clone recursive, you're going to get the core code base, including all of our plugins that I'm going to talk about here in a second. So the core code base has all of the logic and code for connecting to databases, all the code and logic for how to execute planning algorithms. It'll have all of the stuff for loading a GUI. It'll have all the API information and all of that. So everything that's essentially core to running the system. You need nothing else if you just wanted to run core, and you'll have a terminal application that's bundled alongside of it. And you can access that through Netcat, which I'll show you in a minute. The core code base is only 700 lines long, and it is a Python application. It's spread across several different files, but it's only 700 lines long. It's very tiny, and it's intentionally that tiny in order to deploy your C2, because that's what this is here, is a command and control center. You can deploy that into an actual network itself that you've compromised if you didn't want network traffic going out. And so at 700 lines, it's very easy, small to move around, and it's very unnoticeable. Outside of that core code base, when you do that recursive clone, you're going to get all these things that we call plugins. And these are going to be separate Git repositories you're going to see up in the MITRE GitHub space. And the recursive clone will pull them in automatically, and it's going to dump them into a plugin directory in the root of the source code. And so the first one we have here is the chain. So this is a repository that we call chain mode, and chain mode is the new stuff. This is going to have a REST API. This is going to have a GUI. It's going to have a bunch of like odds and ends in here that are going to allow you to do some pretty cool stuff. This is a separate Git repository, so when you clone this and you do the plugins, it attaches this to the core code base. Next one is Adversary. This is our classic adversary emulation tool. This is essentially CALDERA 1.0. We bundle this up into a separate plugin itself, and we attach it to the core code base. So if you wanted to use the classic CALDERA stuff, you can do so by just including that plugin. Third one is Stockpile, and this is where I'm hoping we get a lot of community interest and activity. The Stockpile itself is a collection of open source abilities, techniques, planners, and adversary profiles. And so we have bootstrapped this with a collection of our own. We're hoping to get some good involvement here to build that out. We have a GUI plugin that gives CALDERA a web application, authentication, login, logout, all those kind of features. We have a agent that we call Sandcat, which I'll show you in a minute here. This is a stealthy, in-memory only agent that will run on any platform. We have two variants, one for PowerShell, one for Bash. And this thing is only about 50 lines long itself, so it's very small, and we have a variety of what we call delivery mechanisms to getting this onto systems. And then custom. So this is, you can add your own plugin if you had a Git repository and you follow just the 2 or 3 different rules that we have for creating a plugin. You can actually create your own, plug it in, and use this to store closed source code that you may or may not want to share with everybody. This is what we do at MITRE. We have our own closed set of plugins. We have shared these 5 plugins that we're getting out to the community. We obviously have our own internal ones that we use for a variety of reasons. All right, to get started. It's very easy. Like I said, it's a very small overhead kind of installation. So the first thing you need to do is clone the code and do it recursively. That way you get all of our plugins. And then once you do that from the root of the project, you do a pip installation on the requirements file itself. It's only about 5 or 6 requirements, so it's very small. Then you start the server. It's just a Python script. The key there is we're passing in a local configuration file, which I'll show you when I start it up here. And then the last part is you deploy agents. Because this is a command and control kind of application, there are 2 parts. You have your CALDERA server, which is our core system, and then you have your agents, which you're going to deploy on any remote machine out there that you want to communicate back with the C2. Once you do those things, what you're going to get is a login page that's available to you. And you're going to get a terminal application that you can log into. The entire CALDERA system can be used from either the terminal or the browser. There's very few differences between the two. All right, before we dive into a demo, I want to talk about terminology. So, because I'm going to be using these terms as we kind of roll through, and a lot of these will make a lot of sense to you guys. So CALDERA, core system that's communicating with agents. When I refer to CALDERA, I'm going to be referring to the server side only, not the agents. Those are separate because the rest of the system, like I said, you can bring your own rat. Doesn't matter. When I talk about CALDERA, I'll be talking about that server. Abilities. This is going to be a specific task or set of commands, which you can write in any language that can execute code. Very similar to the ones I showed on screen a few minutes ago. An adversary is a threat profile that essentially encompasses a set of abilities. And this is a good way for you to create repeatable tests in case you wanted to run an adversary against a network every day, every month, that sort of thing. Let's see, an agent. That's going to be an individual computer that's running a rat of any flavor. The one that we're releasing with this is Sandcat. But you can have your own rat, and an agent will be any computer that's running it. A group is a collection of agents. It's easy. An operation is going to be the start to finish execution of an adversary profile against a group. Terminology out of the way. Okay, so mission number 1. This is a fun one. And this is on the GitHub as well, by the way. So if you are looking at GitHub, you'll see this. So what do we want to do? If you have a MacBook, you can follow along with this. We want to perform reconnaissance on a compromised OS X laptop. So what we need to do here, the employer needs a list of the user's preferred Wi-Fi networks. They want to do some surveillance, some Big Brother stuff, so they want to know what this user is connecting to. Maybe his home, maybe his office, iPhone, who knows. We want to grab that and collect anything else that we can really quickly. We want to get out of town. Leave no trace. We don't want anything on that box to indicate that we were there or that we ran commands. And the one caveat is the laptop's AV scans in full every minute. So we need to do all this in less than 60 seconds. Otherwise, we're going to get caught. And that's going to be our first mission that we're going to roll through. So let me hop out here. All right, I think it's big enough. All right, so the first thing we're going to do is I'm running a MacBook, as you can see, run-of-the-mill, nothing special. I have the code cloned. I did my pip install. That's good. I do not have my internet on because I don't trust any of you. So let's see what we can capture without me being on the internet. So let's go ahead and we're going to run the server itself. And you can see there it booted up real quick, just a Python script. And you can see there it loaded some plugins. So you can see Stockpile, Sandcat, GUI, Chain. These will obviously be familiar to you from that slideshow I just went through. So it loads them at runtime. So if you add new plugins, you reboot, it'll load up your new plugins and make them available. This goes ahead and it starts the system up, makes it available at a configurable host import, and then tells you that it has indeed started. All of this is obviously very configurable, and I'm going to show kind of the two ways in now. So let's start down here. All right, so the first thing to note is the terminal application. Once you've got it booted up, all you have to do is run netcat localhost, and the port by default is 3/8 and a 0. Once you run that, you're going to get this funky looking terminal that just shows monitor with a couple of different carrots here. What this is so Caldera is built entirely on a Python library called async.io. With that, it uses a library called AIO HTTP, which is an async REST API framework. What this terminal is built on is it injects you directly into that Python process, which gives you complete control over anything that's happening. So as you're writing plugins, you have the ability to actually intercept anything happening within the entire system and make modifications server side. So if you wanted to do something in the middle of, say, an operation, add a new ability or so forth, you can actually do it right from here. So the first thing I'll do, like always, is run help to see what I have at my disposal. I have a variety of things, and they're all going to be 2-letter keystrokes, which I plugged in to try to keep it to things that you can do with one hand to make it quick and easy. So you just have to learn about 7 or 8 things. The first one is, let's actually roll through the ones that are going to be most useful here for the order. AG is going to show me all my connected agents. I see nothing. That means I have nobody out there running my stuff. So now I got to go get an agent. So how do I get an agent? Maybe I wrote my own, or maybe I want to use Caldera's built-in one. I'm going to use Caldera's built-in one. So I'm going to hop over to the other way that you can actually interface with Caldera, which is through the browser. And you can see I'm at localhost quad 8, and I'm logging in with the default credentials of admin. Once I'm in, I get a home page here that's going to show me all the plugins that I have loaded up, and the ones that have red links on them mean that they have configuration abilities that I can click into, essentially splash pages. So when I look here, I can see, okay, I have Sandcat right here. It tells me a little bit about what that agent is, so I'll click in. I get this nice looking splash page. Sandcat's is quite literally a desert cat that leaves no footprint, hence the name of the route that we have here. It's designed, you can obviously write it to a file, but it is designed to run only in RAM. And as I scroll down here, you can kind of read that quick description. You'll see that we have 2 different, what we call delivery commands that we have published on the page here. First one's super long and convoluted, and it's a PowerShell command. That one is so long because there are so many different versions of PowerShell, and that will ensure it works on all of them, at least all modern ones. The one below is going to work on any bash system, so a Mac, a Linux, that sort of thing. And if you are familiar with Bash, I'm going to run this one first. This will jump out to you, but essentially what we're doing here is we are curling a file, which the Sandcat agent is simply a bash file that's about 50, 60 lines long, and we're going to curl that off of the C2 itself, and then we're immediately going to start it in RAM so it doesn't touch the file system. So let me just copy it here, and I can pop over to, thought I had it here, yeah. I pop over to here, and I'm going to run it directly in shell. That way we can kind of watch and see what the logs do. You can run this no hup, you can run this, we have a variety of delivery mechanisms, stick this on a USB if you want to have a lot of fun. You can deliver this however you want. So once we start this up, we can see immediately it registers with the command and control setter, Caldera. And then it starts checking in. By default, the configuration is going to check in every 60 seconds until it realizes it is inside of an operation, when it actually speeds up the check-ins. So with that running, I should be able to look at my terminal now and say, okay, do I have any agents out there? Perfect. So there I can see host name. I can see how many times this host has checked in, last time it checked in. I can see which type of execution I can send stuff to. I can see it's running bash, so I can send it bash commands. And then I can see, very importantly, the server variable or the server location here. Now you can see this shows localhost quad 8 on it. This is the agent's knowledge of where Caldera lives. Every agent that you deploy out in a real network might have a different perspective on where Caldera is actually living. One agent might think it is at an IP address. Another one might think it's at a FQDN. So it could vary. So every agent actually tracks where it thinks Caldera is independently. And you'll see how that kind of ties into some of the abilities that get driven here. So the next thing I want to do is I want to see if I have any groups. So I'll type GR, and I can see in fact I do have one group, and it's called client. Now, how did that group get created? I can create groups manually if I want, or when I start the agent, I have the option of starting an agent within a context of a group. That becomes very important when you do lateral movement and you want to send the agent from one machine to another. You might want to start it within the context of a group. That way, when it starts checking in, it can immediately join a running operation. All right, so we're good there. We've got an agent, we have a group. Now we want to see what we can actually do. So AB is going to show me the loaded abilities that I have. So you can kind of flip through these names and descriptions and kind of see what is available. You can do things like scanning Wi-Fi networks. You can sleep for a minute. You can leave a note on the host machine, find out the AV, find domain controllers, ARP, all sorts of different things. These are the loaded abilities. Now I'm going to hop out of the terminal for a second here and go to the code base because I want to show how this ties in at this point. So inside of Caldera, looking at the code, we have our plugins directory right here, which if I dive in a little bit deeper, I'm going to see all the plugins that I have available. If I go into the stockpile, which is where all of the abilities live, I'm going to see the ability directory, the organization by tactic, and each one of my individual ability files. So these are what got loaded when I booted up Caldera for the first time. If I want to add my own, just drop in new files, reboot, and those abilities will be accessible to you. Now I see them here. I can copy any of these, and this is going to be true of the entire terminal application. Almost all of the commands in here you can run on its own, or you can do on its own plus one parameter, usually the ID of whatever you're doing. So AB plus the ID is going to show me the actual command for that ability. So in this case, I want to say, okay, dumping history, what does that actually do? Okay, that's going to cache the active user's history, so I can grab that from the terminal. And you can do that for any of these abilities. Once I'm kind of satisfied looking at the abilities, I can flip over and type AD and see my built-in adversaries. So we've got two built-in adversaries, mission 1 and mission 2. We're going to roll through and do mission 1, which is tied to the GitHub mission that I posted, as well as the mission in the PowerPoint that we're actually executing here. Following the standard of the terminal, if I want to see what mission 1 actually does outside of reading that description, just bash discovery, I can do AD1, and I'm going to get all of the commands that mission 1 adversary actually does. So this is the couple of important parts here. You're going to see obviously the commands running in this last column. So you can see the first thing it's going to do is unset history. It's going to cap the bash history. It's going to look for the broadcast IP, essentially where's that router. It's going to do some ARP. It's going to download some files. It's going to run some Wi-Fi scanning tools, all that sort of stuff. The important thing to note when you're looking at an adversary is to look at the phases. So Caldera, this kind of ties into the planner now. So Caldera is going to run, when it runs the operation, it's going to go top to bottom on the phases. So it's going to run everything that's in phase 1 first. It's going to run everything in phase 2 second, and so forth. So you can granularly control the order of your abilities and how they're used if you want. So I can see here I have a single thing in phase 1. What I'm doing is I'm saying for sure I want to unset history as the very first command that gets run. That's absolutely, I want to do that. So that's why there's only one thing there. You'll see there's 1, 2, 3 things in phase 2. There I'm saying I don't care the order of these. Caldera, you figure out what order you want to run them in, but I want these 3 to run before I start phase 3. And so that's how you can kind of think of those phases. The other important note as we're looking at an adversary is going to be this little section here. Let's see if I can highlight that. Now this is a global variable inside of Caldera, and this ties into how agents know of Caldera at different locations. So there is a variable syntax in Caldera that's a hashtag and curly braces, and the global variable of server. There are 2 global variables inside of Caldera, server and group, that Caldera can figure out dynamically. So we can see right here this command, if I copied and pasted this into a terminal, it's not going to work. But when Caldera feeds this ability to a given agent, it's going to know which address that the agent thinks it's at, and it's going to feed it that address. Because it looks, it notices it has that variable, and it does that swap before it actually gives the command to the agent. So that's something to keep track of. And then we can see here that this is a good example for something else, which is the fact that you can download any file that you want from the Caldera C2. So you can store malicious files, you can store keyloggers, you can store Bloodhound, you can store anything you want within the C2 itself, and then you just download it through the file download REST API. So once we're happy with our adversary and we say, okay, we're good with this guy, let's go ahead and queue up an operation. So we already have our agent up here running. So to queue an operation, I'll do help so you can follow along. This one takes a couple of parameters. They're all very shorthand. So it is QU, the name of the operation. We're just going to call it test1. And then we need to plug in the adversary ID, the group ID, and then what I kind of refer to as the jitter fraction. So what I'll explain with that one is the agents can be configured dynamically to check in with the C2 at different time periods. Right now it's checking in, as you can see, every minute. So every 60 seconds it's firing off a check-in. Check-ins are all happening over HTTP or HTTPS. Like any normal website is going to happen. What I can do when I start the agent is I can start it up and say, okay, I want it to check in somewhere between 2 and 5 seconds. I don't want it to be noticeable that I'm like doing something every 5 seconds. So I can add this jitter fraction in and kind of play with that. This can be as big or as small as you want it, based on essentially a nice little stealthy action. So when I do this, it queues up the operation, but it doesn't start it. So this kind of sits in a queue pattern, so I can look at the operation if I want by typing OP. And I can say I do have an operation ready to roll. That start is more of a queue kind of activity. But it's right there, it's ready for me to go. So if I want to start the operation, I do ST1 for the ID of the operation and kick it off. Now at this point, I'm waiting for the first check-in of the agent to happen. So it's rolling it every 60 seconds. The next check-in it gets, it's going to notice that it is in a new pattern. So you can see here it's running workflows, tail in the log there. I'm going to flip out of that one and show the server log. So you can see the server logs happening at the same time, see how Caldera is rolling through the phases. Now from Netcat again, as I'm sitting here, I can tail the operation by passing the ID in, and I can see, man, I'm already 5 things in. So the first thing I did was unset history, very predictable because I put that in phase 1. Now I catted bash history. I'm rolling through the list in order of phases, and then here's kind of that important part with the server variable. Note that this is no longer a variable. The command that was fed to the agent got swapped out, and it put in the actual server address there. Downloaded what I wrote a very small, easy bash Wi-Fi manipulation tool, and stored that in. That's part of the open source code as well, specific for Macs. And so it downloaded that little tool set into the temp directory. It went ahead and it scanned Wi-Fi networks, and then it looked for preferred Wi-Fi networks, which is that last command there. And then let's see if it's done. And then I can see it removed the Wi-Fi toolset. So it unset history, it removed anything it wrote to file, and it got out. Now if I compare that first execution time to the last one, my goal was to get out in less than a minute. Definitely got out. It was, 35 seconds. I was able to get start to finish from the time of the first execution to the last one, and I was even able to drop a Wi-Fi toolset onto the box and then remove it before I got out, make sure the AV doesn't catch me. For any of these commands you see here, you're going to see off on this left-hand column something that we call the link ID. This is part of that decision chain that happens. So we would look at this operation and say that's the decision chain. Every link is a decision or a row in it. So what I can do is I can look at any of them and see the results by typing RE for result. And let's say if I'm interested in my bash history, you're going to see a lot of probably commands and stuff. So let's see what I was able to capture. So this is coming from whatever remote machine. You type in the link ID, you're going to get the entire output of whatever happened in the shell. So I get all sorts of fun stuff that comes from that. See what else I might have. So RE, like maybe I want to see who am I. That was the fourth decision that was made. Okay, I can see the active user's name. So I'm going to be able to like scan through all of these results and look at them. The one that I was tasked with in the mission was to get the preferred Wi-Fi networks, which is link ID number 9. And I was able to grab those preferred networks off of the machine. Mission complete. All right, so when I'm happy with the terminal and everything looks good from there, I can launch all these operations. This is a very minimal mode. It takes very little code. Like I said, the core code is only about 700 lines. This only relies on the stockpile and the Sandcat agent plugins that you plug into the system, and you're off and running. You can run your own agent. Like I said, it's very easy to do. You just plug it in. I'm going to drop out of the terminal at this point. So you're able to kind of follow these logs and see, oh, there's one thing I wanted to show before I hop out of the terminal. If you're looking at the operation that I just ran, the entire decision chain here, you'll note one thing different. Let me show them side by side. So here's the adversary and the adversary set of abilities. And then here is the operation that ran, and you'll notice something slightly different outside of the server variable. You're going to see in the actual execution, this command was run even though that was not a listed ability of that adversary. So that is what we would call a cleanup command. And this is an optional thing that you can add to any one of your abilities. So I'm going to actually pop this one open and show what I mean. So this one is a discovery ability, and it is right here. So this is the full ability that is, in this case, downloading that Wi-Fi toolset. You can see the last block here, which is an optional block. It's called cleanup. If you add a cleanup block to any ability, you can write an additional shell command in there to clean up whatever that ability did. So if you started a process, maybe you want to stop it. If you dropped a file, maybe you want to remove it. So the idea here is putting the ability in your hand as the operator to reset the environment back to scratch, back to what you had it in. Now, at the end of an operation, CALDERA is going to roll through all of the cleanup actions that it has. It tracks them as it rolls, and it's going to roll through them in opposite order. It reverses the order of them. That way it can essentially rebuild your chain backwards running those cleanup commands. It's all in your hands. If you don't include cleanup commands, it's not going to do anything. If you just do one, like in this case I had one, it did that single action. So that is something to be aware of. All right, so with that said in the terminal, I'm going to hop out of there and hop back to the browser and go to home. All right, so from here, back to kind of the home page of CALDERA, I can click into what we call chain mode, which is everything you just saw from the terminal, but from the browser at this point. There's obviously a lot of reasons why you might use a browser over a terminal and vice versa. Depends on which environment that you're actually working in. So what you're going to see here is we call this area the canvas. So it's just a blank area. We designed the ribbon up here to look and feel something like the Microsoft. You know, Microsoft's really good with design, so we went with Microsoft Ribbon. And you have a few options here. So everything that you did in the terminal, you do here. So if you want to manage groups, you click the Manage Group button, and it's going to drop a section onto the canvas that shows you all of your agents that are running, a little bit more user-friendly to filter through them if you want to search for a certain one, if you had a lot. You can see how many check-ins and groups it's part of and all that sort of good stuff. I can create new groups. If I didn't start an agent in the context of a group, I can go ahead and create them here. An agent can have many groups if I wanted to attach many things to it. This is a clear canvas button. It allows me to kind of reset the UI if I want. Next option, I can manage abilities. Here I choose any of my attack tactics, such as discovery, and then I can pick any one of my abilities, and it's going to fill in this little table here that's going to show you all that same information, but in the browser, a little bit more familiar. What you can also do from the browser as well is all of these fields are editable. So if you want to edit an ability in line or create a new ability, you can just hop in the browser. If you didn't want to handle a YAML file, because they are very intimidating, you can just hop in the browser and write them in here. All right, the next part, you can manage adversaries. So here you can either view or you can add new adversaries, depending on what you want to do. We'll look at the two existing ones. So the one we just ran is called Stockpile. It has 9 abilities, and you can see it's a little small up there, but you're going to see the name of the ability, the phase it's in, the tactic, and then you have the ability to remove abilities if you want to. So if I wanted to remove this ability, I can just drop it off. I can save the adversary and I'm good to go. That way I don't have to, again, adjust the YAML file where adversaries live. If I want to add new abilities, all I have to do is find the ability ID that I'm interested in, determine which phase I want to put it in. Say in phase 1, I want to figure out the AVs that are on the machine, drop it in, and I can attach it. You'll see it pop in here. I can save it. Boom, it has that ability. If you're in the middle of a very large operation, you can do this in line, and as the operation's running, what CALDERA is doing is it's checking its set of abilities every iteration of the planning logic that happens. So after every decision, it checks back and says, do I have more abilities? And so you can actually add them in and say, oh man, my operation's not working. Maybe I need to feed it something different. Go ahead and drop them in, and it will know that. So once I'm happy with my adversaries at this point, I can kind of show what the next one is, which is mission number 2. Only 3 abilities in there. This is all open source PowerShell stuff that'll work on Windows and Macs, which I think I have enough time to roll through a quick one here. And then you can manage operations. So let's go ahead and start one from here and kind of see what it looks like. I can select all the operations. This is test 1, which I just ran, by the way, so you can kind of see what it looks like. This is all synced between the terminal and the browser through an embedded database that gets created the first time that you start up CALDERA. So I'll kind of show that real quick. So when you first start up CALDERA, you will see a core.db file get created at the root of the project. This is a SQLite file that gets dropped in and has a specific type of structure and schema to it. Everything that happens within CALDERA is going to get dropped into that database, and that is what the API uses, that's what the GUI is using, that's what terminal, everything is using that embedded database. All right, so let us roll through one more operation here and kind of see what happens. So I'm going to stop my agent here. I'm going to open up PowerShell, obviously the open source version, and this is that long PowerShell string that is on the SANCAT page that is going to start up the PowerShell variant of SANCAT. So when I do that, what I'm going to get is the same registration. I'm going to get the same fact that it's checking in, and I'm off and running. So what I can note here is if I pop to the browser and I go look at my groups, let me refresh, I can see it's all the same with one addition. It's now realized that that same host swapped over from being a bash executor to a PowerShell one, so this is going to accept PowerShell commands at this time. So I was able to kind of dynamically switch the executor. One other thing I didn't mention on the host is every host, when it checks in, gets what we call a unique PAW print after SANCAT. And our unique print we're using right now is host name plus the active user. And that's in order so we can have multiple agents running under different usernames. And that's just a quick, easy way to do it. All right, so we have our SANCAT agent running in PowerShell form. So now I'm going to hop over to Manage Operations. I'm going to click over to add a new one. And we'll call this Test 2 with Mission 2. And the same group. I only have one group at this point. So we'll go ahead and start it off. I'm going to refresh the page, so it'll show up in my drop down here. If anyone wants to put in a pull request for that's been driving me nuts. All right, so I can see here the second mission has started. Get my information at the top. Started at this time. It has not finished. I'm waiting for that. And what you're going to see being built here dynamically, this part does refresh, is you're going to see a timeline that's going to be built of every decision that gets made. So the first one was discover system processes. So if I click on that, you're going to see the decision ID, in case I wanted to look at the results. Status code. Status code is going to be what actually happened on the box, what the shell responded with, what time the host collected it, what time the host finished it, and the actual command that ran. So we're going to give that a second to kind of pop in. And we can actually look at this, and we can see it registered, it checked in twice. So we're just waiting for the next check-in to execute get process. All right, that executed, so now it knows it's part of an operation, so now it's going to be starting up quite amount faster. And so we can see that the next thing it did ARP, it ran that. The 0 status code means it succeeded, and then it identified the active user, and then it successfully completed itself. So if I want to look up any of these, like I want to know, hey, what are the system processes? That was the mission in mission 2. I can click the show results here, and I can drop in the decision ID. And just like I did that through the terminal, if I want to see it from this perspective, I can do the same thing. This is going to give me all the processes that are currently running on this MacBook. So that's a nice handy feature. Like I said, all of this is stored in the database, so you could take that database file, email it to somebody, they could open it up in their CALDERA, and then they could view everything. So a quick, easy way to share stuff. If you are on the blue team side, I did write one thing that would be useful to you guys, which is everybody on a blue team is going to be very familiar with Elk and Splunk and so forth. So everything running inside of Caldera uses a custom logger that I wrote to plug into Elk and Splunk and so forth. And so the custom logger is in the logger.py class. And this simply, I don't know if you can read that or not, but all logs will log to the console automatically. That's the first place it logs. The second place it's going to log is a hidden log directory at the root of the project, where it's going to put all of the logs for operations in one file, all the logs for plugins in another file, and so forth. So it's going to separate those out so you'll have those accessible. But then the third thing is there is a switch that you can set inside the logger. If you have an Elk stack or a Splunk stack, that you can turn it on. And then in addition to those other two things, it will stream the logs in real time to one of those logging databases. So if you're doing a red versus blue kind of operation and the blue team wants to follow along, they can see every shell code and command that's being run, and the timestamps that they're collected and what time they're executed and so forth. So it creates for a very easy way for information to be shared between those two. All right, let's check on that operation. Yep, and we are complete there. All right, so I'm going to hop back to the PowerPoint to make sure I got through all of my slides. All right, second mission, we did have time. We completed it. It was only 3 things. If anybody wants to expand on that, by the way, I wrote that adversary last night before I did the push-up because I just wanted to have a PowerShell one, assuming that some people here obviously use Windows machines. It only has 3 abilities on it that I gave it because I ordered pizza and I ran out of time. So if anybody does want to add to that, actually before I finish up that slideshow, I will show this real quick because it's actually a very serious question if anybody wants to do. So if you were to look at the plugins and you were to look at the stockpile, which is where all abilities, adversaries, and planners live, you'll see an adversaries.yaml file. And this is super easy. So if you have abilities that you have added to the system as YAML files, this other YAML file called adversaries.yaml is essentially just a list of all the phases tied to which IDs are going to go inside of each phase. And all it has to do, that's what it takes to build one of these. We're in progress right now of building things such as threat profiles after APTs and fin groups. There's no reason why we can't emulate them in YAML format. And so if anybody does want to take a stab at helping enhance actually either one of these, Mission 1 or Mission 2 guys, feel free to go at it. And Mission 2 one obviously needs some help. I'd like to build these out so our example ones have 20 to 40 abilities and do some more extensive stuff. The Wi-Fi one's kind of fun, but we can go even further than that. All right, to make sure that I got through this. All right, what's on the horizon? What are we working on? This is a very active project. I've been at MITRE for about 6 months. I've been leading development on this pretty much since I got on board. We just did the open source release, obviously, so that's the push out to the community. Really want to get community involvement. We think that this is going to be a really big tool to be able to use in red team operations. This is something that I will use myself, alongside Metasploit and other tools that I already use, because I think that this is going to be something that defenders are not going to anticipate, especially with the fact that you can bring your own rat in case one does get burned. You swap the rats in and out, you add plugins, you can do lots of different things. So we're going to be doing a lot of future development on plugins and new integration points. We're going to be adding tools like Metasploit, Cobalt Strike, Red Canary, all these different tools that have both abilities that we can port in, as well as techniques and lots of different things when it comes to data. We're working on preceding information into operations, so when they start, they don't start without any knowledge of a system, but they start with knowledge. So we're working on all these different integration points where maybe you run a whole Metasploit recon mission, and then before you actually do your operation, you dump that data into Caldera, you start, and now I start the decision making with a bunch of knowledge. Other things we're doing, we're going to update a lot of our documentation. We're pretty low on that right now. Our readmes are pretty extensive, but we're going to kind of roll in some much heavier stuff. But I'd say, yeah, the readmes are pretty extensive at this point. But we want to do demo videos. We want to do some specific tutorials on how to add techniques. Obviously, it sounds pretty easy, but we want to have that written down. And then we want to do plugin development workshops where we can show anybody that's interested in the development side. This is how you build a plugin. If you want to write a rat, here's how you build a plugin for a rat, just so people have that ability and knowledge. And then we're obviously, this is still been siphoned off into the R&D portion of MITRE, so we're working on enhanced planners that we have in-house that we're starting to spin up new and more complex ways of making decisions outside of the sequential planner that you see here. This is my contact information. Feel free to hit me up on Twitter. Andy is our project manager. Feel free to hit him up as well. So grab either one of those. We do have a support email for CALDERA. Those do go to me. So if you do email that, I will see it. And then that is where our code is. Handful of papers there in case you want to read a little bit more about kind of the research angles of the decision-making logic that we use. And that's everything that I have, and I have time to spare. So any questions from anybody out there? Yes?
Is there anything in place as some sort of stopgap to prevent it from being used maliciously?
We're working on handcuffs, but no, we don't have anything that would be a stopgap for that. So that's more of a, if it's in your hands, this is a very powerful tool, as you can imagine. This can do quite a bit. I would say the biggest stopgap is the fact that we have a more powerful version in-house that isn't this.
Repeat the question over the microphone.
Yeah, the question was, is there any stopgaps in place to stop this from being used maliciously? Other questions?
Is there a task or project of trying to convert the CVEs into abilities?
There isn't one yet, but that is something, that's one of the integration points that we've talked about, but we haven't prioritized yet. But yeah, going through the actual modern, recent CVEs and starting to drop them in. The question was, is there any effort to get CVEs and convert the CVEs into abilities?
You said each client had its own representation of what the server was. Does that also mean that it can be routed through different clients, or does it need a...
Nope, absolutely, yeah. So the question was, because every server has its own knowledge of where CALDERA is, does it have to communicate directly, or can it talk through, say, a proxy or something like that? The answer is it can absolutely talk to a proxy. Most of the configurations that I use, actually, so I spent a lot of my career mimicking, and I've gotten to be a bad person for a lot of my career, mimicking APT groups and hunting them and so forth. So what I've seen them do in the wild is actually set up things like a reverse load balancer. Imagine that. If you're, what they'll do is set up something like HA proxy, say come up with 100 HA proxies out there, but with one C2 behind it. So really your opposite case. And then as IP addresses get burned on their proxies, they'll just chop them off, and they still have 99 more proxies ready. So I actually use this majority of times in that kind of infrastructure, where I will deploy this behind a proxy, and then my agents only know where the proxies essentially are. Other questions?
Do you use any sort of like built-in privilege escalation to deploy it out?
Yeah, that's a good question. Do we use any built-in privilege escalation to deploy this? So you saw me run in this example our built-in kind of delivery mechanisms, which are intended to run under any user permission. So it doesn't matter if they're privileged or not, they can run that as long as they have access on the network to send out an HTTPS request. We do have in-house abilities that do privilege escalation. We're going to be pushing some to open source, and we're looking for more. So if people have privilege escalation that they want to drop in, feel free to drop some abilities in that do that. It can absolutely run it. And that's one of the cool things to kind of see it do, is pass an ability that does privesc, watch it drop down into that user, or start a new shell for that user. That way you have two agents running, one privileged, one not. And then you can obviously do things like lateral movement as well, in any possible way that you can think of. Other ones? Cool. All right. Feel free to hit me up, like I said, through one of those contact mechanisms. Otherwise, I'll be kind of out in that lobby area for a few minutes. So feel free to come grab me. But otherwise, thanks a lot, guys.